Here are examples of interval notation when we're looking at them with actual numbers. So instead of A's and B's, we've got numbers in here. So I'm looking at number one, a verbal description of the real numbers. I've got x is less than 8. I want all the numbers that are less than 8. And all the numbers less than 8, not including 8 would be fine. So something along those lines. Then I want to sketch a subset on the real number line. This should not be the read number line, it should be the real number line. Sketch the subset on the real number line. So here's the number line. I've got 8, and I want all of the numbers, not including 8, that are less than that. And part C, state whether the interval is bounded or unbounded. Okay. Bounded means that there's some sort of an end to it. And this situation, this x is less and so this is bounded. We say that it's right-hand bounded. We would also call this a finite interval. There's some end to it. Number 2, a verbal description of the subset of real numbers. We're going for all the numbers in between -1 and 3. We are not including -1, but we are including 3. So you should write some version of that. For B, sketch the subset. The subset starts at -1, goes to 3, does not include 1, does include 3, and we're talking about all the numbers in between them. State whether it's bounded or unbounded. There's clear bounding on this one. It's bounded on the left and bounded on the right. Even though we're not including that -1, it still has a stopping point. We cannot go past that -1. Number 3, we're looking for an ending point at 3, and we're looking for all the numbers that are to -infinity from that. So I think if we write the graph first, that'll be the easiest way. 3 has a bracket on it, so that's a closed circle. We're going to -infinity. -infinity and infinity can never have a bracket on them because they keep going forever. There's no end to them. Well, when we look at this, we can then create some sort of an inequality from it, where this actually is saying x is less than or equal to 3. And so we can say we're looking for all the numbers that are less than 3, including 3, so some version of that. And then state whether it's bounded or unbounded. This is again bounded on the right-hand side by the number 3. We do not have a bounding on the left-hand side, but the overall version of this is bounded.